Hello, in this video we'll formulate a linear programming model given the linear programming problem over here. So this is so far our problem. In the problem we see that a manufacturer of lightweight mountain tents makes a standard model and expedition model for national distribution. Each standard tent requires 1 labor hour from the cutting department and 3 labor hours from the assembly department. Each expedition tent requires 2 labor hours from the cutting department and 4 labor hours from the assembly department. The maximum labor hours available per day in the cutting and assembly department are 32 and 84 labor hours. Okay, this is the maximum labor hour that we can utilize for the cutting and assembly department. If company makes a profit of $50 per unit on standard tent and $80 on per unit basis on expedition tent, how many tents of each type should be produced or sold or manufactured each day to maximize total profit? Okay, so far this is the statement of the problem. Now in this problem we say that what is the objective function. First we look for objective function. আমরা যে খেয়াল করি এখানে আমাদের কি ম্যাক্সিমাইজ অর মিনিমাইজ করতে হবে. So far it discuss about profit and it says that how many tents of each type should be manufactured to maximize total profit. So our objective function should be profit and that profit should be maximized. So we maximize profit. So for the sake of explanation we take z equal profit and we maximize z, in this case our objective variable. Okay, now to find the profit objective function, now we have to find some information from the problem. The problem says that the company makes a profit $50 per unit basis on standard tent and $80 per unit basis on expedition tent. And we also do not know how many units of standard and expedition tents the company sells. তো আমরা ধরে নিই company sells x1 units of standard tent and x2 units of expedition tent. So we can say now we can find the profit from selling x1 and x2. So profit from selling x1 is 50 multiplied by x1 because $50 from per unit of x1, and profit from selling x2 is 80 multiplied by x2 because $80 on per unit of expedition tent. So in total we have these objective functions. So we maximize z equal 50x1 plus 80x2. This is our objective functions or profit function. We have to maximize this objective function. So once we state the objective function, now we have to find our constraints that should be satisfied to maximize this profit. Okay, to maximize to find the constraint for the objective function that we need to be satisfied, we have to read once again the problem. The problem says that each standard tent requires 1 labor hour from the cutting department, 3 labor hours from the assembly department, and each expedition tent requires 2 labor hours from the cutting department and 4 labor hours from the assembly department. Okay, so these are the constraints so far. That means we have some resource constraint over here, and also we are given another constraint is that we can use maximum 32 and 84 labor hours for the cutting and assembly department. So এটা হচ্ছে আমাদের কনস্ট্যান্ট ইনফরমেশন. এই কনস্ট্যান্ট ইনফরমেশন ইউজ করে আমরা ম্যাথমেটিক্যালি আমরা কনস্ট্যান্টগুলোকে স্টেট করতে পারবো বাই ক্যাটাগরাইজিং দ্য এলিমেন্টস. ওকে, এটা হচ্ছে আমাদের স্টেপ নাম্বার 2. ইন দিস কেস উই স্পেসিফাই এন্ড ক্যাটাগরাইজ দ্য এলিমেন্টস আন্ডার দ্য ডিফারেন্ট ক্যাটাগরি. ওকে, now first we see that we have a 2 department, cutting department and assembly department. In the same token we have standard model, 2 models, a company sells standard model and expedition model. From the problem we see that the cutting department standard model requires 1 labor hour from the cutting department, 3 labor hour from the assembly department, and expedition model requires 2 labor hours from the cutting department, 4 labor hours from the assembly department. And in a sense we see that maximum available labor hour for the cutting department is 32 and assembly department is 84 labor hours. এখন যদি আমরা খেয়াল করি তাহলে এটা হচ্ছে আমাদের ফার্স্ট কনস্ট্রেন্ট ফর দ্য কাটিং ডিপার্টমেন্ট and this is our second constraint for the assembly department. That means that we also know that company sells x1 unit of standard model, x2 units of expedition model. So x1 per unit of standard model requires 1 labor hour from the cutting department. So this is x1, 1 multiplied by x1, and also per unit of expedition model require 2 labor hours from the cutting department, so 2x2. And in the cutting department we have maximum labor hours available is 32, and that should not be exceeded. That means less than or equal. That's called maximum sign. And in the case of assembly department, we see that each standard model requires 3 labor hours from the assembly department, so 3 multiplied by x1. And each expedition model requires 4 labor hours from the assembly department, so 4 multiplied by x2. And this should not exceed maximum labor hours for the assembly department is 84. And we also know that the value of x1 and x2 should be positive or should not be negative. Should not be negative, not positive. It could be 0 or positive, but not negative. So in a sense, we see that this is our two constraints. And we also know that because maximum labor hour means we have a maximum limit over here, and since we have maximum limit, we have less than or equal sign. This is called that this resource uses should not exceed the maximum limit, and also this resource uses should not exceed the maximum limit 84 labor hours for the cutting assembly department and also for the cutting department 32. So once we state the constraints in the mathematical manner, now we can formulate the complete problem. So this is the complete model. So far we have seen our objective function is 50x1 plus 80x2. That's called objective function. That's called profit, G for profit, and we have to maximize the profit function. And our two constraints are, so far we have seen from the above, is these are the two constraints, x1 plus x2. This is the resource uses for the two model from the two department, cutting department, for the cutting department for expedition model, standard model, and in the cutting department we have maximum labor hours 32, and that should be satisfied, and so on for the assembly department. In assembly department we have maximum labor hours is 84, and that should be satisfied also. And we also know that the value of x1 and x2 should not be negative. It could be positive, it could be negative, it could be 0, but it should not be negative. So that's called non-negative constraints. So this is the complete linear programming model that we have formulated so far. So far we have seen how to formulate a linear programming model given the linear programming problem in real life. And that's all from this video.